Hello. Alright. This is how to do screen space light maps in JavaScript. First, I will explain to you what is a screen space light maps. And I think it's helpful to think of it. It's kind of like a layer, a visual layer on top of the game world that controls what the player can and cannot see. It is a light map is a map of areas of light and areas of darkness. Areas of darkness are harder to see, areas of lightness are easier to see and glow. Here we can see an implementation of this in an old Zelda game. We have the game world, the light map, and combining the two. It's okay, so when I was researching this, they use the term multiply, but I don't think it's very accurate to say. It might be additive, but I did not end up using additive. I ended up using something else, but it's a filter that exists on top of the game world, where blobs of light are drawn over game entities where you want there to be light or to glow, in contrast to the darkness. You could probably do this the other way around too, but I do not see very many applications of that in many games, unless you're trying to do something really interesting. Here is Celeste that uses light screen space maps. You can see the glow around each of the green gems and the strawberry to signify some importance to the player. In fact, they are useful. Celeste is a platformer game, and you have a speed boost in whichever direction you choose, but once you use up, you lose a charge. You lose a charge, but you can regain a charge each time you hit these crystals. And you can see the path that you're supposed to take um, to get to that strawberry and make it out. In Hopeless, the Dark Cave, it's an old mobile app game, but I found it really fun. Um, Essentially, you're playing as a survivor group of light blobs. They're trying to survive against the darkness, the horror in the unknown of in the dark. And you shoot them, but they come out and they can try to grab and yoink the light blobs into the darkness and never be seen again. And the light map is used to illustrate them disappearing to the unknown. We can also see it here in League of Legends. It's called the Fog of War, but the Fog of War does a little more than what a light map does. The light map only only filters, not necessarily remove from sight. Because if it was only light map, you would see enemy players on the map. But in the Fog of War, there's stuff that you just cannot see unless they're part of the game world normally, like all the time. The terrain, the map, the stuff. But not the players, not the hostels, not the jungles, camps, if you're familiar with the term. But you can only see what the player is allowed to see, is the main point. In JavaScript, I found out to do this, you need two canvases. One, the game world. The second is the light map that is on top of the game world. The second canvas has to have no background, otherwise you just cannot see the first canvas. And it should allow click through if you want to click things on the game world. Because if you will only be clicking on that second canvas if you do not allow click through. Uh, Also, if you want to enable that first canvas, so the game knows you're actively using it. I think that's the right way to phrase it. Um, when using this version of light maps, we're limited by what CTX can draw and what it can color. The easiest way is just to apply RGBA values to the fill and draw circles and rectangles around whatever objects that you want to use. Canvas gradient is complicated. It does allow gradient effects, but I have not found much success in implementing it correctly. Uh, Good luck if you're trying to use that. But the easy way is just circles. It's gonna be plain. It's gonna be a little boring, but gets the job done. And you can make it a little dynamic if you draw multiple circles or multiple rectangles in that same space. We're also abusing the global composite operation XOR. When they overlap, when shapes overlap, um, that part will be opaque or no, we have low opacity. You can see through it. And other spaces will be harder to see through. That is the darkness. Now, to show you the code, on the HTML side, we have the stack ID. We have two canvases. They're inside a stack, and we control their z index. We have set the position absolute, and we control the pointer events. This is some idea on how to put them on top of each other. You can play around with it, if you want. Um, but this is a simple way to just make sure they're on top of each other. I'll also make sure the background there's none for the second canvas. I decided to implement as a game object, so it's more intuitive, but you can apply it to the game engine if you really want. But sometimes you don't want to use it, so I set it as a game object. If on certain game levels you decide to remove it or add it back in. As a game object, it goes through the draw loop and it draws on the second canvas. It does not matter the order because it's always drawing on that second canvas. It will clear whatever previous light maps there was. It's saving any draw information or settings. That's what does save does. And then it's gonna loop through each game object and check if it's an entity and it has light. Um, it's just a boolean value. If it's true, it's gonna draw the draw light function on that entity, such as here. This is just gonna be drawing from the center of the player. This is the player, and it's gonna have the radius, and then it's just gonna be drawing around with the fill style. And note the alpha has to be pretty high because we're using XOR, so it's gonna be the opposite when they overlap. Then that is important because the closer to zero, then it's more clear, and then XOR it's going to be the opposite, which is intense alpha, which you can't really see through. This is going to draw a circle. When that's done, it's going to draw the darkness over it and apply the XOR. That's basically what's going on. You can play around with these values. You can, if you change these the RGB values, then you get a tinted effect. So you can kind of control what color shows through if you want there to be color. And then when that's done, then it loops over for every draw. And if it happens that you want to remove it, I suggest a clear function because it won't automatically remove on its own. You have to remove it manually, or say if you're removing from the world, then call its clear function, which will just clear the light map. Now onto some game demonstration from the games I've implemented this in. Here we have Entropy. Uh, Essentially, this is a level where it's not dark at all and there's no light map applied. But as soon as they enter the next level, we have the light map applied. I decided to make it dynamic to simply illustrate some enemies' visible range in which they would detect the player if they enter inside of it. And it expands. The Spectre Knight expands their light radius, and see the player, and then I have him chase after the player. I am in a terrible spot, and I just died. But you can see what's going on, and I made it so if I decide to leave the area, um, the Spectre will shrink back its radius to a different state. Um, but you guys can figure that out. And I'll just die here, I guess. But I'll show you a different implementation. This is Miku on a stage, and she's just bouncing around, and it's whatever. And I can apply the light map to show you it's a spotlight on the Miku. If I expand outwards, you can see the actual light map itself, which is pretty neat, and I would say. Uh, I think that's it. Good luck to your games and have fun. Mess around.